Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Yes, so it's good to see all of you again, and in this video we are going to continuing our discussion on continuous random variables with a lecture 4 of 5. So I do hope that all of you are ready with your handout of the lecture notes in your hand right now. So then, in this subtopic or in this lecture, we will look into the cumulative distribution function. Okay, the term of cumulative means that we adding or we call the result from one to another. Okay, and then sketch the graph of cumulative. Find the cumulative distribution function from a cumulative distribution function, and find the median from the cumulative distribution function. So if x is a continuous random variable with a probability density function fx for all real x, then the cumulative distribution function of x is given by a capital letter of f, x equal to integral from negative infinity to any value of x of the function ft dt. Okay, so fx is in fact given by the area. Given by the area under the curve of fx from negative infinity up to x, indicated by the shaded region. Okay, so which means that we are actually talking about the area between the curve or the function and x-axis. That's why we integrate the function of ft dt, just like we call the previous notes here. And cumulative distribution function of fa equal to the probability of x less than or equal to a. Okay, so for this one here, we can simplify as an cumulative of b minus fa. So with all these symbols, it's better we look into the examples so we can see clearly what it's all about. Determine the median from cumulative distribution function. The median divides the area under the curve into two halves. So then, if the median is n, then integral from negative infinity to m fx dx equal to 0.5, which means that cumulative of function until the x equal to m here equal to 0.5. So x is a continuous random variable with probability density function as given here, fx equal to 1 over 2 times 2 minus x for the domain of x from 0 until 2 and 0 otherwise. Okay, so meaning here from x equal to 0 until x equal to 2, the function given here is 1 over 2, then 2 minus x. So the rest of this is 0. Okay. So find cumulative distribution function of fx. Okay, so look at this. There are three we call parts of the domain here, which is first is for this one here is x less than 0. Then the next domain is between 0 until 2, where x is between 0 until 2, and the next one here is x greater than 2. So three different parts here. Okay, it's separate into three parts. Then here now. So the first one, for x less than or equal to 0, not equal, less than only. Okay. For x less than 0, then fx equal to integral from negative infinity until x, where we substitute the function as a 0 respect to the t. Okay, so this one will give you 0. And then for x lies in between 0 until 2. So accumulate means that the first one here, accumulate from negative infinity until at any point less than 0. Let's say we put a t here. Okay, we substitute with x here, x less than 0 from negative infinity until x is equal to 0 here. Okay, because of the function of 0. And then for this one, fx equal to from negative infinity until 0. Negative infinity until 0. The function is 0 dt. Okay, plus with from 0 until any value of x from 0 until 2. So just imagine that from 0 until 2, then x in between 0 until 2 here anywhere. Okay, so we put it here as a 0 and add x with a function of 1 over 2 to minus, okay, change the variable of x into t dt. And of course, this is going to give you 0 plus with, okay, what about this one here now? 1 over 2 is a constant. Integral 2 minus t, come up with 2t minus t squared divided by 2. Okay, sorry. T squared divided by 2 from 0 until x. Okay, 0 plus 1 over 2. Okay, now it's time for us to substitute these two t's first with x. So, to replace the t with an x here, meaning that we get 2x. And then x squared divided by 2. X squared over 2. Minus, okay, substitute these two t's with 0. 0 and 0 equal to 0. So then, okay, we may ignore this, it's a 0. Okay, it is 1 over 2, then 2x minus x squared over 2. It is equal to, okay, 2 divided by 2 equal to 1. So then x. Then x squared. 2 divided by 2 times 2 equal to 4. Okay. So this is a function then. And then 4x greater than 2. Accumulate means that we integrate from negative infinity until 0, plus with 0 until 2, plus with 2 to any x to positive infinity here. Okay, so fx equal to integral from negative infinity until 0 dt plus, okay, from 0 until 2, 1 over 2, 2 minus t dt, sorry, okay, from 0 until 2, 1 over 2, 2 minus t dt, and plus with from 2 to any value of x greater than 2 here. So put an x here, okay, 0 dt. In this domain, less than 0 and greater than 2, the function is 0 and also 0. There's only domain between 0 and 2, there's a function of half 2 minus x. Okay. So now, this give you 0. Then this one here, 1 over 2, okay, integral of 2 minus t respect to the t, you come up with 2t minus t squared divided by 2 from 0 until 2 plus with, okay, and this one is here also gonna give you 0. So only this left, since that this is 0 and this is 0, this left here now. So 1 over 2, substitute t with 2 first. So 2 times 2 equal to 4. Then minus 2 square equal to 4. 4 divided by 2 equal to 2. Minus, so substitute t now with 0. 0 and 0, 0. So then 4 minus 2 equal to 2. 2 times half equal to 1. Okay. Therefore, with all this solution here right now, we come up with a conclusion of cumulative distribution function equal to 0 for x less than 0, and then x minus x squared divided by 4 for x lies in between 0 until 2, and then 1 for x greater than 2. Okay. Question B. Probability of x lies in between 1 until 1.5 equal to f1.5 minus f1. Okay, so guys and girls, 1.5 lies in between 0 until 2. Okay, again 0 until 2, so 1.5 lies in between here, 1.5, and 1 also here. Okay, so then just imagine that if we take this value, this function, okay, x minus x squared divided by 4, because both of these values of x lies in the range, in the domain of 0 until 2. So first one here, substitute 1.5 here and here. 1.5 minus 1.5 squared divided by 4 minus, okay, f1, so substitute 1 here and 1 here, 1 minus 1 squared divided by 4. Okay, so you may use your calculator, okay, it will give you 3 over 16. And median, for question C, median, which is Fm equal to 0.5. Okay, so just imagine that if we take, since that there is no function here, the function equal to 0, and there's no function here equal to 0, the only function in between 0 until 2. So the middle should be here, somewhere around here. Okay, so then Fm equal to 0.5. Take this function of x minus x squared over 4, substitute with n, m minus n squared divided by 4 equal to 0.5. Okay, then multiply with 4. So 4 times m, 4m, 4 times negative m squared divided by 4. So 4 divided by 4 equal to 1. M squared equal to 0.5 times 4, then 2. Okay, so you come out with m squared minus 4m plus 2 equal to 0. So using quadratic formula, or might be factorization, or just use any method that can give us the value here. So you try by yourself using computer square or factorization, or might be the quadratic formula. then it gives you m equal to 3.414 or m equal to 0.586. Okay, since that m, the value of n should be lies in between 0 until 2. Look at these two values here. 3.4 is somewhere around here. 3.4 is not in the domain of 0 until 2. So this is not one of the answer. And 0.586, yes, it lies somewhere around here. So then the value of m equal to 0.586. Okay, so that is the first example solution for example number 1. Example 2. A continuous random variable x has property density function, okay, fx, small f here. So obtain the cumulative, meaning that from fx to capital letter of x. Okay, sketch the graph and find these two. Okay, determine the median of m. Okay, now let's rewrite the function of fx as our reference here, which is 1 over 16x for x. X lies in between 0 until 2. Okay, 1 over 8 for x in between 2 until 9 and 0 otherwise. Okay, meaning here from 0 until 2 and 2 until 9. Otherwise, so beside these two, the function is 0 and 0. So the first domain from 0 until 2, the function is 1 over 16x. And the second domain here, okay, is between, the function is 1 over 8. Okay, so now the question wants us to find obtain the cumulative distribution function of fx. So we take the first here from negative infinity until 0 for x less than 0. Okay, then integral, okay, fx equal to from negative infinity, okay, until x of the function 0 dt. Okay, the function here is 0 according to this. With a domain from negative to 0, the function is 0. So 0 respect to the t, and this gives you 0. For x lies in between 0 until 2, then the function of fx, the cumulative function of fx here, this, okay, the function in this domain from negative infinity until 0 plus the domain of function from 0 until 2, accumulate, adding up these two functions. We call these two results here, this one and this one. From negative infinity until 0, 0 dt plus 0 until any value of x lies in between 0 until 2. Okay, and the function is 1 over 16t. Okay, change the variable of x to t. Okay, the reason is we change the variable to t for a while. Once we substitute the x into this function variable of t, then we end up with a function of fx. Okay, so this one gives you 0. Okay, 0, and this one here 0 plus integral of 1 over 16. Okay, 1 over 16 integral of t respect to t square over 2. T square over 2. Okay, from 0 until x. So just ignoring this. Okay, this one here, t square over 32 from 0 until x equal to, substitute t with x here, so it gives you x square over 32 plus or minus, substitute then with a 0 here, 0 equal to x square over 32. Then 4x in between 2 until 9. So then fx equal to integral, the first domain here from negative infinity until 0, negative infinity until 0, and the function here is 0 dt, plus with the next is from 0 until 2, and the function involved here is 1 over 16 times x, 1 over 16 times x, plus with the next domain here is from 2 to any value of x which is less than 9, 2 until x which is less than 9 here, and the function involved is 1 over 8. So 1 over 8 from 2 until x dt. Okay, again this give you 0. And what about this one here now? Okay, 1 over 16 integral of x, this one should be 1 over 16 p dt. Okay, and then 2x 1 over 8 dt here. Okay, so integral of t dt equal to t square over 2 and plus with 1 over 8, integral of 1 dt 1 over t here. Okay, so for this from 0 until 2, and this one here from 2 until x. So 16 times 2, 32. 2, substitute t with 2. 2 square equal to 4. 4 over 32 minus, substitute t with 0 here. 0 square divided by everything here is 0. Plus with, okay, substitute t with x, so 1 over 8x minus, substitute t with 2. So 2 here, 2 divided by 8 equal to 1 over 4. Okay, so this is 0. 4 over 32 equal to 1 over 8 plus with 1 over 8x and minus 1 over 4. And this gives us okay, 1 over 8x. Then make this one as a denominator with an 8 here, 8, and this is 2. Okay, 2 over 8 simplified as 1 over 4. So 1 over 8 minus 2 over 8 minus 1 over 8. Or it is equal to 1 over 8 x minus 1. Okay, so okay, it's not end yet. We get another one here. 4x greater than or equal to 9. Okay, so it is integral from negative infinity until 0, 0 dt plus from 0 until 2, the function involved here is 1 over 16t dt plus from 2 until 9, 1 over 8 dt, okay, plus with from 9 to positive infinity 0 dt. Okay, so accumulate 0, 2, and 9. Accumulate from one result from negative infinity until 0, one result, okay, plus with the function in the domain of 0 until 2, and then plus with the recall integral from the domain 2 until 9 of the function 1 over 8 dt, plus with the last one here. So this we consider as F9. Okay, so F9, let's say if I solve this using recall integral 1 by 1 here, this can give you 0, and this also can give you 0. Okay, integral of 1 this 1 over 16 integral of t square over 2 from 0 until 2 plus, okay, integral of 1 over 8 respect to the t, 1 over 8t from 2 until 9, and this is 0 here. Okay, so substitute, 16 times 2, 32. So substitute t with 2 here, 2 square equal to 4, 4 over 32, 1 over 8, minus t, substitute is 0, 0 over 32 is 0. Plus with, okay, substitute t with 9, give you 9 over 8, minus substitute t with 2, so 2 over 8. Okay, 1 over 8 plus 9 minus 2 equal to 7 over 8. So look at this one here now. 1 over 8 plus 7 over 8 equal to 1. Okay, actually that we can also use, because from here until here, from the beginning of this until here, we can define this as a F2, F9, sorry, F9 plus with integral of 9 to positive infinity of 0 dt, where this is 0, just like this one here now. Okay. Okay, so F9, where I can use this result of this, okay, use this into here, okay, which is 1 over 8 x, take this x as a 9 minus 1, 9 minus 1 equal to an 8, 8 multiplied with 1 over 8 equal to 1, yet still the same, okay, either one. Okay, so now cumulative distribution function of this, we take it one by one. Okay, this is the first one here. Okay, this is the first one, this is the next second one here, and this is the third, and finally it is equal to 1. Okay, so slowly one by one. The first is 0 for x less than 0. The next is x squared over 32. So then x squared over 32 for x in between 0 until 2. Then 1 over 8 multiplied with x minus 1. 1 over 8 x minus 1 for x lies in between 2 until 9. And finally, it is equal to 1 for x greater than or equal to 9. There you go. Okay, to sketch the graph of this, okay, is a function of cumulative distribution function of x and also x here. Okay, according to this one, 0 and 0 until 2, which is x squared over 32. Okay, class, x squared over 32, x squared. This is quadratic. Might be the graph with something like this. Okay, the graph of x squared over 32. But then, with a domain of 0 until 2, meaning it's just something like that here. Okay, until 2. So from 0 until x equal to 2, so this is a graph of x squared over 32. Then next is 1 over 8, x minus 1. This is linear. So linear, you can sketch the graph of this on the other paper. Or let's say, if I come up with, let's say, y equal to 1 over 8, x minus 1. Okay, so then when x equal to 0, okay, when x equal to 0, y equal to negative 1 over 8. And when y equal to 0, okay, when this one equal to 0, just imagine that here, 1 over 8, x minus 1 equal to 0. 1 over 8, x minus 1 over 8. Okay, take this one as a positive here, 1 over 8. Then x equal to 1 over 8 divided by 1 over 8. Or 1 over 8 multiplied with 8 over 1, which is equal to 1. Okay, so the graph of this, okay, 0, negative 1 over 8, 0, negative 1 over 8, somewhere around here. Okay, and y equal to 0, x equal to 1. Okay, so this is the graph for this function. But then the domain is only for 2 until 9. So just imagine that if we cut this from x equal to 2, cut this until 9, until here. So the rest of this, okay, we may delete all this. This is the only graph involved. So then we come with 9 and up here. Okay, so this is the graph of x squared over 32 from 0 until 2. This is the graph of linear 1 over 8 times x minus 1 from the domain of 2 until 9. 2 until 9 is a linear. And then finally, x equal to 1, fx equal to 1 for x greater than or equal to 9. Okay, meaning here, this is y equal to 1. And this is equal to 1 over 8. Okay, so 3 different functions combines together. Okay, so which I think that I'll clear this first. And also here. So class, this is the graph for this function of cumulative distribution function. Yeah. Okay. And next question. What was the question now? Find, okay, question C, find px greater than 1 and px from 1 until 5. Okay, So for this one here now, the first one, property of x greater than 1. We may use 1 minus property of x less than 1. Okay, the reason that we come up with this formula, because we have two functions, which is domain from 0 until 2, and then from 2 until 9. If we like to find that, we call this one here, meaning we integrate from 1 until 2 dt plus 2 to 9 dt plus with 9 to positive infinity. So we need to find out this and this, adding these two to get this answer. Okay, because 1 lies in between 0 until 2. So we can find this one here, the function we call integral between this domain and also here. So why don't we just make one, we call simple, accumulate value here from negative infinity until here. Okay, 1 minus f1, because this accumulate from negative infinity until 0, 0 until 1. Okay, so 1 minus, okay, this one, which function involved in between 0 until 2? Okay, this one, okay, for this one here, from 0 until 2 with a function of x squared over 32. Okay, so then here 1 minus x squared over 32. So substitute x equal to 1. So 1 squared over 32. Then equal to 1 minus 1 over 32 equal to, just imagine that this is 32 over 32 equal to 1. Minus 1 equal to 31 over 32. Okay, and then property of x from 1 until 5. So we take this as an f5 minus f1. Okay, and f5 lies in between 2 and 9, and the function involved, which is the function of 2 between 2 and 9, the function involved is 1 over 8 x minus 1. Okay, so 1 over 8 x minus 1, so 5 minus 1 minus f1. f1, 1 lies in between 0 until 2, and the function is x squared over 32. So 1 squared over 32. Okay. 5 minus 1 equal to 4. 4 divided by 8. Okay, 4 over 8 minus 1 over 32. Make this as a, okay, 8 multiplied with 4 equal to 32. So 4 times 4 equal to 16. 16 minus 1 equal to 15 over 32. Okay. And then the next one, we need to find the median. Okay, let's say if I choose f2. Okay, let's try f2 where 2, which function involved here? Okay, 2 equal to 1 over 8. 1 over 8 x minus 1 for x equal to 2 here. Okay, let's try. So it is 1 over 8, then 2x minus 1 or 2 minus 1 equal to 1 over 8. 1 over 8. 1 over 8 is less than half, right? Less than 0.5. So then, median lies in between x equal to 2 and x equal to 9. So the suitable function, or the function I'm going to use here, is this one, 1 over 8 times x minus 1. Okay, so we substitute 2 into this function here just now, we get 1 over 8. So less than 0.5. So meaning that from 2 until 9, there should be, okay, from 2 until 9, there should be a value of m that divide the area between this and divide this area. Okay, this is 1 over 2 and this is another half. Okay, 1 over 2 and 1 over 2. So m in between here. Okay, so then 1 over 8 m minus 1 equal to 0.5. Okay, or make it 1 over 2. Okay, never mind. Multiply 8 here and multiply 8 here, left and right. So 8 divided by 8 equal to 1. 8 times 0.5 equal to 4. And minus 1. Then n equal to 5. There you go. Okay, so next one. To find the probability density function from a cumulative density function. Just now we discussed on how to find the, just now, the previous discussion just now, we talk about on how to find the probability density function to get a cumulative distribution function. Now, for this topic, we are going to, when given to us the cumulative distribution function, it's our job to find out what is the probability density function, the other way around. So then, fx equal to derivative of function of cumulative fx divided by respect to the x. Okay, class, why do we come up with the differentiation? Yes. Do you see all this function here? Integral, integral, and integral. Okay, so opposite then we are going to differentiate the function of cumulative to get a probability density function. Opposite then. So now the cumulative distribution function fx of a continuous random variable is defined as this one here. Find the values of a and b and find the probability density function of fx. Okay, so I think that I'm going to rewrite this here. Okay, fx equal to 0 for x less than 0. X squared over 3. X squared over 3 for x, from 0 until 1, and then x minus ax squared minus b for x in between 1 and 3, and then 1 for x greater than or equal to 3. Okay, this is a cumulative distribution function. Okay, now, first, for x in between 0 until 1. Okay, we ignore this because differentiate 0 for this one value of 0. Of course, it will get 0, so we're not going to waste time to look at this one. We straightly look at this one here now. Okay, 0 until 1. So then, Because 0, substitute here, 0 squared divided by 3 equal to 0, meaningless. So we look at this, the value of 1 here. So f1 equal to 1 squared divided by 3 equal to 1 over 3. For x in between 1 and 3, okay, so we refer to this function x minus ax squared minus b, substitute with 1 first, so f1 equal to x equal to 1 minus x equal to 1. 1 squared is 1 times a minus a and minus b. Okay, and class, because the value of x equal to 1 and 1, so we can simply combine these two. 1 minus a minus b equal to 1 over 3. 1 minus a minus b equal to 1 over 3. Then negative a minus b equal to, bring this 1 to the side, become negative 1. Here 1 over 3 minus 1 equal to negative 2 over 3, or a plus b equal to 2 over 3. And we put this as an equation 1. The same function here, but then we look at the value of x equal to 3. f3 equal to, again, 3 minus a, 3 squared minus b. So 3 minus 3 squared equal to 9 times a equal to 9a minus b. Okay, and then for x greater than or equal to 3, then it is equal to 1. For x greater than or equal to 3, so then f3, take this value of x and make it here as an equal to 1. And now look at this one here. Both f cumulative 3 and 3. So we put this together as 1. So 3 minus 9a minus b equal to 1. Then negative 9a minus b equal to 3. Minus 3 here. 1 minus 3 equal to negative 2. Then 9a plus b equal to 2. Equation 2. Okay. So from these two equations, equation 1 and equation 2, there are two variables of a and b. Okay, now let's say if equation 1 minus equation 2, b minus b. Okay, so then a plus b equal to 2 over 3 minus 9a plus b equal to 2. So b minus b, a minus 9a, negative 8a, 2 over 3 minus 2. 2 over 3 minus 2. 2, we take this as a 6 over 3. 6 divided by 3 equal to 2. So 2 over 3 minus 6 over 3 equal to negative 4 over 3. Negative 4 over 3. Okay, so divide by negative 8 left and right, and give you a equal to 4 over 3. Okay, 8a equal to negative 4. 4 over 3 and a equal to 1 over 6. Okay, you may try this here. So when a is 1 over 6, you may substitute this either into equation 1 or equation 2. It's all up to you then. Okay, so substitute this into equation 1. So a, no. A is 1 over 6. 1 over 6 plus b equal to 2 over 3. We use equation 1 here. A plus b equal to 2 over 3. Then b equal to 2 over 3 minus 1 over 6. Change this in the form of fraction with the denominator of 6. So 3 times 2 equal to 6. 2 times 2 equal to 4. 4 over 6 minus 1 over 6. 3 over 6. sorry, three over 6, or b equal to 1 over 2. So a is 1 over 6, b is 1 over 2. Okay, now it's time for us to complete the fx. Okay, before that, okay, for x in between 0 until 1. So f1 equal to 1 over 3 times 1 equal to 1 over 3, and then 4x in between 1 until 3. Then f1, oh sorry, I repeat the previous process, sorry. Okay, just now, wait a minute. Okay, if I, okay, look at this one, a 1 over 6, b 1 over 2. So I write here again, fx equal to, from 0, which x less than 0, and then x squared over 3 for x in between 0 until 1, and then x squared minus ax, where a equal to 1 over 6, okay, here, x squared over 3, and x squared minus ax, where a just now we found it is 1 over 6, and b is 1 over 2. So we write this in the proper way, the proper form, x squared minus a, 1 over 6x, and then b minus b, which is 1 over 2, for x in between 1 until 3, and then 1 for x greater than or equal to 3. Okay. Okay, now, for x in between x in between 0 until 1. So then fx equal to derivative of the function x squared over 3, okay, x squared over 3 respect to the x, and this give you, okay, differentiate x squared 2, okay, x of 1 divided by 3, so 2 over 3x. For x in between 1 until 3, then the fx equal to derivative, okay, x squared over 3, here substitute into this we call process of fx equal to derivative of x squared over 3 respect to the x. So now this one here, okay, x squared minus 1 over 6x minus 1 over 2 respect to the x. So derivative, differentiate x squared, 2x, differentiate 1 over 6x equal to minus 1 over 6, differentiate negative half equal to 0. Okay, so this one we simplify as a 1 minus x over 3. Okay, so now fx equal to 2 over 3x, this one, for x in between 0 until 1. Next is here, 1 minus x over 3 for x in between 1 until 3 and 0 otherwise. Okay, So that's all for today. Okay. I do hope that this video helps you to continue with your tutorial, try to make you understood with the recall content of this topic. And that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.